normal. Should we leave Blinky there? We may as well. Why not? He can hang out until he starts obscuring the screen, and then we'll just we'll make other arrangements. We can maintain the chat overlay, which will probably obscure things as well, because I haven't found any way. I haven't implemented a way to fade things out, so it'll block the entire screen, but that's okay. Where are we up to? Where are we up to? We had gotten all the way. Oh yeah, at the end of the previous one, I had just gotten blocked on segment 33.762, and then I finally figured it out. So let's make sure this is still working. Yeah, and it finally passed. Thank goodness. That was a hard one. I struggled with that. Well, it was hard to me anyway. Okay. So it looks like it's still all passing. Doo-doo. Okay, return to the... Oh, no, wait. Continue editing. And what was the last debug we got? My sister was over for the holidays, I think to check on me. Make sure I haven't gone off the deep end. I know I caused some worry. Her kids saw me working here and suggested I could swap the web for TIS-100 specs. Surf the web. So even kids are on about internet, online, blah, blah, blah. OX7. It's a racket. I don't care about the information superhighway, and I never will. All right. Let's go back to the previous segment, to the segment list. And there's a sandbox, but I don't think we need to do anything about that. It's not actually part of the game, it's just a test. So we'll can that. All right. So the next one on the list is signal pattern detector. I have a bad feeling about this one, but we'll give it a crack. Create new program. All right, what's our communication failure? It's a very open screen, this one. Debug. A noise from the garage. But turns out it was nothing. So now that I have plenty of free time, I bet it wasn't nothing. Now that I have plenty of free time, I might as well get back to this. Keep my skills sharp while I look for a new job. Uh-oh, got fired. Dude got fired. Randy is his name. Randy got fired. Continue. Okay. Read a value from N. Look for the pattern 0, 0, 0. Write 1 when the pattern is found. If not true, write 0 instead. Interesting. Okay, so all of this should be 0. And then right here, we write a 1, and we can keep writing 1s until, right, okay. Oh, man. Okay, so every time we have to store 3 values, essentially, is what this is saying. And we have to keep updating those values. And then every time all 3 of those values are 0, we have to write a 1. And at all other cases, we have to write a 0. God damn it. All right. This is going to be tricky. This is going to be tricky. I'm worried. Okay, we're going to do it. It's going to be fine. We're going to do it. It's going to be fine. It's going to be fine. Let us try writing. I feel like what I want to do is start at the end, kind of. Like, yeah, no, hang on. I need to understand how I can implement storage, right? in a way, it's kind of like an XOR. Like you just want to wait until something is always 0. So if I put a 0 here, and then I put a 0 here, and then I put a 0 here, and I move all of them, I can't move them right. I suppose I could. Then I read from each one of them. I read this one and it's a 0, so I pass a 0 down. I read this one and it's a 0, and I pass a 0 down. I read this one and it's a 0, and I pass a 1 right. I don't know. Let's just sketch this out. Let's sketch this out. Let's go mov in left. Oh, right. What is it again? Mov up left. Mov right. Right. Oh, no, actually, we have to right ACC. No, hang on. Let's just not worry about memory for a minute. What if I moved it down instead? I just kept moving them always down and right at the same time. Because I have to hang on to a copy. No, I have to... And the thing is, you even have to deal with the first case where there's only one number. So it's like I have to wait for the numbers to... I think I actually have to move them down. It's almost like you need a short circuit. Yeah. I think I may need to do a quick BRB because I see someone arriving home. I should be brief. All right, let's see what we can do here. I was sort of thinking along the lines of using these three as like a battery, or essentially RAM. But I think that's not where we want it to be. I sort of have this vague idea of moving everything through this path, storing it, and if it's 0, moving it down. But I just, I don't know. That doesn't sound right. That does not sound right to me. What is a good test for this? How can we make it work? We need to implement time. I mean, we could do it so that we move them into the horizontal ones. But at all times, we need to know whether we're dealing with the middle one, the left one, or the right one. Yeah. Like no, it's not order dependent. It's if any of them are not 0. The fact of the matter is that if the current number, if this number that comes in is not 0, then we immediately can short circuit 1 as the output. We can immediately short circuit 0 as the output. The output is 0. And I wonder if we always but we still have to store whatever that number was. Although, in fact, if I get a 2 coming in, I can output 0s for the next 3 times, because it will never be 1 while that 2 is in the queue. It's almost like you could say, keep testing one column, or keep testing one box, and if it's ever, oh man, this is hard. What about a counter? That would work, right? If you just count the number of 0s. And if the counter is greater than 3, you output a 1. Can we implement greater than? I think we already did, right? On one of them. Yeah. Yeah, we could do that. So, hang on. I'm nervous because with all these boxes here, it's like it expects a really complex solution. Yeah. But let's see where it takes us. So mauve up. ACC. Jump equal to 0. But it won't, right? There's no jumping. We have to count. Swap. No, hang on. Yeah, we do still have to jump. Jump equal to 0. Increment. And then increment would swap, add 1, and swap, right? I think. Otherwise, mauve 0 down, I guess. Or right. Mauve left down. There's no way this is going to be close to the solution, but I just want to sketch it out.
Can I please take the trap?
Of course. I think I have the keys in my pocket.
It's parked in front of the bin. I can't get to the charger. Thank you.
You're welcome. Okay. Mauve up, down. Mauve up, down. Okay. So all this does is all this does is zero counter, essentially. So let's see, let's confirm that this does what we think it does. So 2, mauve 0 right, jump B, 0, add 1, and swap. Oh, and we also need to move 0. Well, potentially. So this is close, but it's definitely not right. So it's counting the number of zeros. Okay, cool. So that's kind of interesting. Now, how do we do a greater than? So so we need to know if subtracting 3 from it, if it's greater than 0, then we jump somewhere else. Subtract 3. And then jump greater than 0. True, I guess. Or sequence. What is this called? Signal pattern. pattern. Otherwise, add 3 and swap. Okay. And the pattern is mov 1 right. And this one has to have a different case. Mov 0 right, jump B. There's no way this does it, but I'm just riffing basically. Waiting for it to break, which you probably will now. Oh, interesting. So it actually outputted a 1, but too early. Oh, and we also need a case for it to zero out. The counter needs to be accurate at all times, basically. And as soon as it encounters something that's not a 0, it needs to zero the counter. So mov 0 right. And we're going to run out of space, obviously. But mov 0 right, jump B. Yeah. So if we've said that there's nothing, we need to sub ACC, essentially, to clear the value. And we also need to clear the memory. So I wonder if Teddy, what the hell are you doing? Oh, buddy. What are you doing? Hey, cut it out. Excuse me, my dog's about to lose the plot. I brought Tilly in her crate for a timeout because she was being a bit of a brat. And now Ted's decided he wants to go in the other crate. So he's in a crate that's much too small for him. Trying to chill, trying to be a big chill dog. It's not a good thing. Okay. All right. So the task is clear ACC, which is fine, but also we'd have to clear the memory. So we'd have to swap swap sub ACC save, or just save 0 maybe. Oh yeah, save, just save from here. Like that, that would clear the memory. But again, I don't think that's enough. I think this one, where we've incremented the counter, but we have to catch the case where it could be greater than 0 or it could be equal to 0. Yeah. So it is possible to implement all of this in one box, but not if you not with the boxes the current size that they are. So instead, we have to split things up a bit. Yeah. What if we just forward the current count to the next box and then have the next box decide whether or not to output a 0 or a 1? That makes better sense to me. Yeah, so let's do that. Let's go mov left ACC sub, oh no, add 3. No, sub 3. Sub 3. JGZ pat, except it would be J equal to 0 pat. Add 3. Oh, actually, we don't care. We can ignore the value. And pat is, but otherwise we would mov 0 down. Pat is mov 1 down. And this is B. And this is jump B. Cool. So now, in this one, all we have to do is maintain the count. Yeah. Okay, cool. So I don't need testing stuff. All I need is hang on, I did need the increment. So JEZ increment, and increment is swap, add 1, swap, and then this one is always, we always want to move so JZ increment, and then swap, move ACC right, swap. Oh, hang on. Yeah, actually, because JEZ increment, then sub ACC, save, and move 0 right, because that's the current counter. Jump B. Otherwise, the increment is swap, add 1, move ACC right, and then swap. Actually, hang on. Oh yeah, that's right. And so this one should be jump of greater than 0, to pat, jump if less than 0, equal to 0 to pat, move 0 down, jump B. Otherwise, move 1 down. All right, I'm okay to test that. Still zeros. Still zeros. Should be a 1 coming up. I hope. Yes. Okay. Does it break is the question. Ah. So all of those boxes, and we only needed 2 of them, just goes to show the game tells you lies. The game does not tell you the truth. Hey, we got there. That was actually easier than I thought it was going to be. Phew. Okay. We read the thing, right? Oh, yeah, he lost his job. Okay, cool. Return to the segment list. Nominal. Sequence peak detector. This will be like, I've got the thing where I have to measure the sequences, but now I've got to count the sequences or something. Sequences is 0 terminated. Read a sequence from in, write the min value to out, and write the max value to out. Oh, man. This is actual math. Every new problem sounds hard. All right, debug. I am good, damn it. Just as good now as I ever was. But nobody want to hire old, washed-up Randy. Not when all the young folks straight out of school will work 100-hour weeks for nothing. And I'm lousy at promoting myself, always was. Paul had Bill, Woz had Steve. I never had that kind of partner, someone to champion me. It was always just me. Oh, Randy sounds so sad. And he's leaving little notes to himself inside a computer. Sound familiar? Okay. Let's see here. Read a sequence from in. Write the min value to out and write the max value to out A. Okay. Now, I've done a sequence terminated by 0 thing before. I think the thing here is to keep writing values to both columns, right? So we've got two columns of data. If we keep writing to both columns and then evaluating both columns to see if until we get a 0, then I feel like that should be okay, right? Because all you have to do is keep replacing it if it's smaller or larger in this case. Okay, so the immediate thing is mov up ACC, mov ACC right. Mov left ACC. Should I start saying move? Maybe. Okay. Now, we would only save if the value was less than the previous value. In this case, or more than the previous value here. So I guess, no, actually, We need a copy of the previous value to compare it with. I'm wondering if we just shove that left. Let's handle the case where the sequence is terminated. Oh, and you also have to output it every step. What? No, that can't be right. Oh, I see. 1473. Yeah, okay. That's why there's so few values. All right, so let's handle the 0 case. Jump equal to 0, out. And then jump B. Out would be mov ACC. Out would be swap mov ACC down. Sub. Well, actually, you could just leave it there and it would get overwritten. And then back would already be 0. Yeah, that makes sense. Jump equal to 0, out. Jump B, mov out, swap, move ACC down. And then this becomes move up, down, move up, down, move up, down. Okay, so we've got the 0 termination part done. Now, let's see. We need to store the new, well, we've got the new value in ACC, and we've got presumably what was the previous lowest value in back, or 0. That's the trouble. The first value is always going to be 0 because that's what we're putting in the, that's the terminator from the previous sequence, presumably. So, and or in the case of the start of the program, it's 0 anyway. So how do we... Yeah. We need to... The new value is coming in to... We can't compare it to 0 because that's not going to work. 0 is always going to be lower. So we have to either... I assume that the sequences can't contain 0 because the 0 is the terminator. So we have to swap, check to see if that's 0. So swap, jump equal to 0. I guess skip. So skip would be just swap, because we're saying whatever the other value was, we want to keep it. And then jump B. So skip is swap, jump B, and swap, jump equal to 0, skip. All right, so that takes care of the first value. And actually, yeah, because no matter what it is, it's always going to be either greater than or either the lowest value or the highest value, right? And then in the event that it's not, I hope we have room to do this, but so we've swapped it. So oh, actually that's wrong. So if we get a 0, if we get a 14 in and zeros in back, we've jump equal to 0 out, which it isn't. We've swapped it, so 14's in back. Jump equal to 0 skip, which is true, it will skip. But actually we don't need this. We can do this instead. Jump equal to 0 B. And this jump B would be redundant except for the fact that we're going to use it. So we're saying if the other one is 0, then there's already nothing we need to do. Okay, so now we've got a test to see if the second value is less than the first value in this case. And the second value is currently in back. So I'm wondering if we should save a copy of it on the left-hand side and then just reread it again, like mov ACC left. And then this would be mov right, right. And this one would be, actually you could do the comparison without this jump equal to 0B thing, because it'll still work, right? There's no need to short circuit that. Actually, hang on. We only want to do that if we haven't jumped. Mov ACC left. Okay, we've swapped. So now we potentially have two numbers, 14 and 73. 73 has been moved left, so it's coming back in. So we want to determine which one is less. So we subtract. We did this before. We had to subtract it, and if the value is greater than 0, then the left-hand one is greater, right? So sub left, yeah. So in this case, that would be 73 minus 14. Jump greater than 0. Actually, we want to skip if it's less than 0, right? So if it was, hang on. Yeah, you want to skip if it's greater than 0. So jump greater than 0, B. Jump, and otherwise just write it, because it'll be equal anyway. So save. No, hang on, you need to add again. Shoot. So do we need 2 copies of the number? Swap sub left, jump greater than 0, B, save. So we don't actually want to save it because what we've got is the subtracted number. So do we need 2 copies of it? No, because what happens if this isn't... Oh, no, this... This is tricky. Huh. Okay. So hang on, I want to see this actually working for a second. I'm kind of getting confused about which number's going where. We get 14 in. And we move it right. If it's 0, we moved it out, which it isn't. Move it left. Oh, okay. Yep. Swap. Sub left. If it's greater than 0, we would go to the beginning, which it isn't. Otherwise, we would save, but obviously negative 14 is not the right result. Okay. All right. That helps a little, I think. So this is not going to be right, is it? We need 2 copies of that number. And then 0 it out. So yeah, so hang on. So sub left and then add left, essentially to reset that number. So we need 2 conditions, yes and no, essentially, or lower. Lower is add left. No, hang on. If the result is greater than 0, then that value was actually higher. In which case let's just go high. In which case we add left. Wait a minute. No, 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 no. If it's greater than 0, then the value that's coming in is lower. Oh, I'm so confused. All right, cool. Yep. So low, low, add left, save, jump, B. But we're going to run out of space for sure. Otherwise, what do? We still need that number back. Low is add left, save, jump B, and high would be just add left. Wait. Oh, shoot. Uh-oh. Hi. How are you, folks? Thank you so much for the raid. Finn. Of course it's Finn. And, hey, Robot knew you were raiding. He knew. Look at that. Finn50 Cat is raiding. Thanks, mate. However, it didn't shout you out. It was supposed to, so I'm going to do it for it. Shout out. Finn50 Cat. There we go. I mean, I don't think that anyone who was already here would not already be following you, but since there was like one viewer, I think that's not a problem. How are you doing, and what did you get done, or is that the wrong question? Should I be saying, was it fun? It was very nice of you to come visit anyway. We're playing TIS-100 at the moment, and it's going pretty slowly. I got to tell you. There's nothing like a game about assembly language to spice things up. It was fun. I was on with Karen. Oh, nice. And Karen started playing Ace Attorney without telling me. So was she supposed to be doing something else? Was that the plan? And it didn't just didn't quite happen. But you know, it's an iterative process and you iterated. Yeah, you know, the thing about iteration is that 1 is an iteration. Plus 1 is absolutely an iteration. You saw this game in the Cerebral Puzzle Showcase on Steam. This is TIS-100, and if you haven't seen it, it's actually pretty cool. Well, for some values of cool. Some people absolutely hate it, but I like it, and it's one of these games. I own all of them, I think, from Zachtronics, and I've played them, but I haven't finished them. There you go. It's New Zealand $5. How can you not buy it? It's like work, but you don't get paid. That is an accurate description. Whoa, full screen doesn't work in this setup. But yeah, you just it's about this guy named Randy who died, and you get given this mysterious manual about the computer that he was working on, trying to get it repaired, and throughout he leaves little notes to you. In the debug sections. This one says, "I'm good, damn it. Just as good now as I ever was, but nobody want to hire an old washed-up Randy. Not when all the young folks straight out of school will work for 100-hour weeks for nothing." This is sounding very familiar, by the way. "And I'm lousy at promoting myself. Always was. Paul had Bill, Woz had Steve. I never had that kind of partner. Someone to champion me. It was always just me." So yeah, he's kind of dissolving into himself as the further along we go, which is kind of what happens to the player who plays the game. But TIS-100, it's very cool and semi-addictive. And they made lots of other interesting games. Space Chem is a really good game along similar kind of lines. Shenzhen IO I've also played a little bit. So I'm thinking about. It does have a very cool story if you can get through the puzzles. Have you finished it? I am only part way through, so I have yet to discover. Yeah, but I'm have vague ambitions of playing through all of them because I really have a lot of Steam games. I gave up because it was too much like work. Yeah, fair enough too. I have a lot of Steam games that I've gone part of the way through and never finished, and I'd quite like to at least do a few of them. And the Zachtronic games have always inspired me. They're just so different and so interesting. Granted, it's a great way to turn people off ever watching me stream again, but that's okay. It's kind of fun. So I'm stubborn like that. I put the dog cam on, but both of the dogs have gone to their crates. I think they're cold. You have to love and leave. You have 2 hours of cardio to do. Dude. Well, good luck with that. And I thank you so much for stopping in. I really appreciate it. Stops me from chatting to myself quite so much, which is never a good sign. Okay. So we were part of the way there, but we were running out of room, I think was the problem here. See you soon. So we've got this situation where we're storing the first value and we move it right. And then we jump equal to 0 out. So then we move it left. And we test it. So sub left, that's negative. It can't be the lowest value. So we save it, and that's wrong. Okay. So in theory, we would do add left, and then jump back to the beginning, or save and then jump back to the beginning, but we're well and truly out of space. So how do we do that? We can't do it in one block, that's for sure. We have to treat the maybe we need to treat the next row as a storage. So instead of trying to maintain everything up here, maybe we only do a bit of processing up there and then move down. Because we're going to run out of room for sure. So, or maybe I move a value left to test it and then store the result in the center column. So I've got a situation where I've got these values. This out column has to be the minimum value, and this one has to be the maximum value of all of these sequences. Tricky. By the way, is chat being echoed on screen? Oh, it probably is, but it's colored very darkly, so it wouldn't. Oh no, it's not there. Interesting. We were trying to fix the overlay earlier, but there's still some bugs with the underlying library I'm using, so it's not quite working as expected. All right, so think about this. If we move the value, we have to copy the value right so that we get it over to this side. So that's correct. I think a lot of this other stuff is not correct though. Oh, out is correct. Because if it's the last value and we're at the end of the sequence, we just move everything down. But this stuff, what I'd like to be able to do, let's just paint the perfect picture. So we move it left, and then we move left, right. So we say left ACC. So we say that this left box is going to do all the calculation for us, and then it's going to save it into here no matter what. And then we get the value and we save it. Jump B, and then out is like we've finished, we're done, we get to go. And we've put the 0 in there. Okay, cool. So that's good. Then our first instruction here has to be move right ACC. We actually need both numbers in there to do the comparison. And we need to store it. Jeez. Have I just moved the problem and it's still a problem? I do believe I have. I think that very thing. What am I doing? Okay, so we'd like it if this box could just send us the number we need to store. And so let's duplicate that structure. Let's duplicate that structure over here. So we get the one from left, and then we move it right. No, we wait for the jump, then we move it right. Oh, we're already doing that. And then move right ACC, save, jump B. Okay, so that's essentially the same structure. We're saying, I'm going to calculate this for you over here. Return lowest, return highest. Okay. Now, how do I do that? I need both values because I need to implement greater than, unless I just save the previous value all the time, in which case the previous value will always be in here. Yeah, that makes sense. So cool. Can I do that without using another external box? Because I can't do that over here. There's a communication failure. Let's find out. Let's find out. Let's go move right ACC. And then so in this case it would move 14 in here, and I would have 14 and 0. I would want to sub whatever was in ACC from whatever was in back. I think that probably means maybe if I just retain the value here, I don't need, yeah. What if I have like high and low? Is that going to work? No, I need to do it in the other box. All right, move right ACC. I might need 2 copies of the number. I think I would have to swap so that the 0 moves in here and the 14 moves in there. Sub right, so we subtract whatever's in the right from 0. If it's less than 0, if it's greater than 0, then the original number was lower, right? Because 14 minus 0 is going to be 14. So jump greater than 0, high. And high would be to move the original number back. This is complicated. I need a copy of the original number that we had. So actually I think swap, move down, but then of course we can't do that over the other side. Move ACC down, sub right, greater than 0, high would be moved down right, and low would be I think we would have to have 2 copies of the original number. And we need to consume them each time. Jump B. And B is begin. Okay. Move ACC down, sub right, jump greater than 0 high. Otherwise it's low, right? So we don't actually need the low section. And we don't need this. My concern is what we do with the down, because there's a down block here, but no down block here. There might be a way to get away with it in one thing though, I just haven't found it yet. Jump greater than 0 high. Otherwise, move right, back to the right. No, hang on. We want the original number. Oh yeah, right, back to right, that's correct. And then jump B. Okay. I think that's right. So my question is whether it'll find the lowest one. I think it will. So let's step through that and see what's going on. So 14 comes in at the top. We store it and we move it right so that the next column can get it. We check to see if it's equal to 0 and it's not. We move it left. And then we have to wait because we need to move it left again. Move ACC down. So 0 goes down a box. And then sub right. Oh, it's blocked. Why is it blocked? Why? Oh, you can only read and write one thing at a time. Damn it. Okay, so I need an instruction down here. You can only be in either read or write mode, not both. So this needs to go move up, up. All right, sub right, which was 0. Wait, what? What happened there? $14 goes across, right? Yeah. So it should be 0 minus 14. Oh, it is. Good. Jump greater than 0 to high, which it's not. Which is interesting because I think it should be jump less than 0 as high. Yeah. So if the number coming in is bigger than the number that exists. Okay. 14 comes in, jump less than 0 high. So we keep the number we had before. Oh. Except if it was 0. We need to be able to handle zeros. Because 0 is the terminator. Oh, this is hard. This is very, very hard. Okay, we need another case. We need to handle what if the number we've got is a 0. Move ACC down, sub right. Swap. Jump equal to 0. Terminator. Term. Mov. Right. ACC. Oh, running out of space. And mov right, right. So we're returning the value that they sent us, basically, as the lowest. We also need to consume the value that was sent down. This is probably the way complicated way of doing this. Swap, and then mov down ACC just to get rid of it, essentially. But then we need to jump. We've so run out of room. Oh, hard. Am I trying to cram too much logic into a small space? Maybe I need to move everything down. Oh, man. I'm eating it on this one. The previous one was so much easier. Okay, we can do it. That's okay. We can do it. We can totally do it. It's going to be fine. We just need to think it through. So expecting this entire box to do all of the calculation for the greater than. What if we just return a 1 or a 0 if it's greater than or less than, and let this one worry about storing it or not. That sounds like a better idea, right? And then we might not have to worry about this. So swap jump equal to 0 term. No, we don't need to worry about that. We kind of do need to worry about the case where the terminator was stored. Maybe if we just immediately save it. No, we have to store the previous value. There's no question about that. So swap gets us the previous value. If it was 0, hang on. Jump equal to 0, false. Oh, wait, the question is the lowest. So jump equal to 0, true, because if it is... just got some ads floating through. Sorry about that. Won't be long. Trust me, nothing exciting will be happening. It'll be me scratching my head. That's what's going to happen. It's me scratching my head. Okay. True is move 1 right, and that's it, basically. And false is move 0 right, jump B. Okay, this has got potential. This has got potential. Jump equal to 0 true, and then jump B is our last statement. So that gets us the issue where our stored value is 0. In which case, the 14 that's being passed through as our first value has to be the lowest one. Otherwise, if it's not equal to 0, we have to sub right. We're also going to have to consume the value that's being passed. Yeah, we'll figure it out. It's going to be like... we don't care about the value, so it's going to be move right ACC, and again move right ACC, and then move 1 right. I don't know if I need the value twice this time. I might not. I probably don't. Let's just check. And then this one would be move right ACC. Ah, false is longer than true. Running out of space forevermore. Okay, move right ACC, move 0 right. So we get rid of the value and then we move our answer back. Okay, JEZT. And actually we probably don't need a false. We can just keep going. Okay, ads are done, I do believe. Now, jump equal to 0 to T, sure, sub right. If the result is less than 0, then the value that was passed in is lower. So jump less than 0 T. Otherwise, clear the queue. And actually we don't need... to get rid of the value in the right column because it's already gone. Ooh, this is promising. I like this. Move 0 right, jump B. Except that we have to store the value. Don't we? Yes, we do. So we do need it twice. And this needs to be move. We wouldn't store the value if we didn't want to keep it. Oh, geez. What if we passed it both values from ACC and from back? So we do a move ACC left, swap, move ACC left. Yeah, and just use this as our comparator. And then we wouldn't have to keep the value. We just take both of them. But how do we... Yeah, okay. So swap, move ACC left. And then no matter what comes back, oh no, we need to detect if it's a true or false situation. Oh, okay. Let's proceed with that. Oh, this is really pushing the limits here for me, but I'll figure it out. Swap, jump equal to 0, true. Right, but now we're getting two values. We need to read both of them. So our first action, regardless, is to go move right ACC. And then sub ACC, sub right ACC. Oh, that doesn't work. Sub right, and that's what it is. And so this will give you, if the second number is always the saved one, then that's actually not what you want. You want swap first. Well, no, actually, it does work. You just have to do it in reverse, right? So jump greater than 0. To true. And this jump equal to 0 thing wouldn't be a thing. So move right ACC puts the 14, puts the 14 in there. And then sub right subtracts 0 from it. And that gives you the greatest. It doesn't solve the problem of what about the 0? Oh man. It does not solve that problem. So maybe I do need a jump. If the second number I get is a 0. To handle the issue of what happens to the saved value. It really only matters at the very start of the program. So sub right, I don't know if this approach is going to work. I think if I was able to use this box, I could see it working, but I don't think it will. So either I move everything down here, I think what is the problem here? If we move the 14 in, it's here. We move it across and store it. And then we swap and we move whatever was here across and subtract that from here. We need to detect the 0. How do we detect the 0? By swapping, I guess. So save. Mov right ACC. Jump equal to 0. I guess T, as in the number that most recently came in is the lowest. In which case you could actually return it, but it doesn't solve the problem of what if it's not 0. So now you need to subtract the value, except that you've just taken away the two values. Oh, no, you haven't. You can... Well, you could move it down, but again, you can't do it on the side. Oh, this is breaking my brain. Okay. What if I'm approaching this wrong? What if we just have one? Oh, no, that doesn't make sense. I think actually that sending the... Let's just remove this for now and assume that there's something that can return a 1 or a 0. Does it even fit in here? If we get the 0 terminal, we jump to out, that's fine. And we assume that the lowest value is always in back. Otherwise, we move the two values left. And then we take... yeah, see, I don't think that works, because how do you test it without moving it back into ACC? I think you have to have something that returns the lowest value of the two, rather than a 1 or a 0. In which case, we have to send both of them. Or this one has to have a memory of whatever is the lowest value. In which case, why can't we just keep sending numbers in here and it just... I feel like this is a job interview, seriously. one that I would probably not pass. But it's okay. It's good. It's good. It's good. All right. Let's proceed on the assumption that this does not return the lowest. This stores the lowest. And we can't use this box because we can't pass it on. So this one is store lowest, store highest. In fact, it doesn't need to be. We can just, wait, hang on. We always send both numbers in both directions. So this acts like a distributor. And as soon as it sees a 0 on either side, it fires the values down. And we'll just do like a little circuit around here. Okay. Let's get rid of that. And let's go move up ACC, move ACC right, move ACC left, swap, move ACC right, move ACC left. Okay. So every cycle, it's always sending both in both directions. Store highest. Okay, I can get with that. So in the first cycle, we're going to get a 14 coming in and being stored here. So we'll get 14 and we'll move it right. And we won't do anything because it has to wait. Damn, it's in write mode. Okay, so first of all, to see this working, we need to go move right ACC and then swap or save. No, can't save because that would erase the previous value. Swap. And, but now you've got 3 values in play because you've got the saved previous value. No, because the saved previous value is here. So you never need to care about, yeah. Yeah, you never need to care about maybe this doesn't store anything. Feels like not enough work. It feels like not enough work, damn it. All right, swap, move, right, ACC. We might need multiple copies of one of these numbers, I'm not sure yet. So this one becomes move left, ACC, swap, or even just save. No, because, okay, we have to assume that the lowest number is in here, which starts at 0. And the thing to do, I think, would be to rule out the 0 detection here. Hang on. So we know that if a 0 is being passed to these sides, then it must be a terminator. Whereas if there's a 0 in here, then we just ignore it, right? So swap. No, maybe we do it. Maybe we deal with it on the other side. All right, move left ACC. Swap. If the stored number is 0, jump equal to 0, skip, or B, which is the start of the, can be the start of the program for begin. Jump equal to 0, B. All right. Because we're never going to store a 0. And if we get a, we could also add an initial jump equal to 0. Out. Which is swap. No, actually save, because we've got our 0 value. No, swap, because we need our previous value. And then move ACC down. I don't think we're going to have enough space. Jump equal to 0, out. Out is swap, move ACC down. I definitely don't think we're going to have enough space, but let's get rid of the comment anyway. It'll at least give us one more row. Maybe we can find a way to spread it out some. Okay, move up, right, move left, down, move up, down, move up, down, move up, down. Okay, now, what happens to the value if it's not 0? So we move this one into ACC. If it's 0, we jump to out, we swap, and we move ACC down. Because it'll never be 0 to begin with, then that should be safe. Otherwise, we swap. And if that's a 0, then we jump to the beginning, because there must have been a 0 stored there initially. Okay. Now, we need to compare the incoming value with the saved value. So we've swapped, and I think we're probably going to need another copy of hang on. We need to swap again, because we're now saying that this value, hang on, jump equal to 0, B. Yeah, so if say 14 is in there, then we need to subtract whatever's now in there. We need to swap back again, because that's our stored. Oh, geez. More caffeine required. Definitely more caffeine. I don't like the fact that we're swapping back and forth and back because it feels wasted. But I'd love to just get it working first. And there is a test that we need to do to check if the initial 0 is what we're seeing, the one that's stored in back. Zombie, how are you, mate? How's Dexter? How's the family? We're staring at black and white boxes again. It's a trap. Yeah, I'm all right. I think I spent most of this week not streaming and feeling a bit poorly, but we're good now. I started up the robot and everything broke, so it's all good. Okay. I passed the previous one pretty easily, and this one is just killing me. It's just killing me. But I'm trying. Okay. So we swap again. What state does that leave us in? We got 14 coming in. We pass it across. We move it there. We jump equal to 0 out because that would mean that it's a terminator. And yeah, jump equal to 0 out, then we swap it back again. So 14, jump, swap if 14 is there, jump B, otherwise swap again, 14 is there. So that means the saved value is there. Fanny was in here a little bit earlier. I think they might be doing the old lurkage. Both the dogs must be freezing because they put them in their crate. They put themselves in their crates. They're the wrong crates. The big dog's in the small dog's crate. The small dog's in the big dog's crate. But they don't seem to mind too much. So no matter what, I need the value that's come in again in order to subtract. But I need not to destroy the value that I'm saving because I'll need it again. I need another copy of it. It's almost like Dexter is asleep next to me on his chair waiting for me to stand up. Yeah. He knows what's coming. He knows what comes next. What time is it? Almost 6. Yeah, so it's like I need to save the value that I want to compare it to and the value that is coming in. I need saved copies of both of them. Man. This one is not easy. And someone's going to come along and say, yes, it is. It's not easy for me. I'm about halfway through the exposed ones, but yeah, this is a killer. So it's doing less thans and greater thans. But you have to remember the value each time. Otherwise, you can't send the output. I wonder if we could make one square just responsible for storage. And then, yeah, and then it wouldn't matter about output. Okay, cool. Yeah, I like that. I like that. I like that. I'm picking up what I'm putting down. I'm picking it up. This is storage. And this is storage. So in that case, all we have to do in here output lesser and output greater. Except if it's a 0, in which case you just output the 0, right? Does this actually help me? Maybe this doesn't help me. Well, it does help not having to remember what it was. So I can just subtract one from the other. And if it's negative, oh, I don't know if this helps me. I really don't. I know how to do it at I mean, everybody knows how to do it at a code level. It's just when you get down to this level, I start looking for some kind of memory, some kind of storage, and there isn't any. Well, there is. You have one value of storage for every square. So let's think about this. We could do a jump equal to 0. Hang on. Move up ACC. Jump equal to 0 out. And out would be swap and move ACC right in this case because it goes over there. But otherwise, we're going to assume that it's the number coming in is lower than our previous number. So we will save and then jump B. And then if we get a 0, which is the sequence terminator, we'll swap to get the stored value and we'll move the ACC to the right and then out. All right, so can we then, with that task offloaded, can we make it better? Okay. Okay, so first of all, move right ACC, swap, jump equal to 0. So that means that there was a 0 value stored all along. So it must be the first line of the program. Jump equal to 0, skip, and then skip will be save. Oh no, hang on. Swap. Oh no, because we've already got the value where we need it. So skip is just jump B. So jump equal to 0 is go back to the beginning. So if it's not, if we've got two values in there, one is say 14 and the other one is 73, that means that the 73 is there. So I think we're going to need 2 copies of the number. And then we'll go sub right. And if the number is less than 0, jump less than 0, less, lower. So the number coming in is bigger than the number. All right, so that's high actually. You should be a gamer. Oh, I should totally do this too. Just in case you get caught in the channel again when no one's there. Besides, you're there just about more often than I am. You're trying to put stuff on eBay. What are you selling? Don't say the dog. Yeah, another sword. I know. I don't want you to count. I hate to think. Okay, jump less than 0, high, and then jump B. So high would be the number coming in is too high. So we would keep the number. Oh, wait. I don't know if this works. Because this destroys the number that was. Oh, we just need to add it back again, right? It's like we need 3 copies of the number. The dog will be buried with you. You should change your knife emote. That's absolutely true. It should be a green sword. It's you're a mod Ronin. You travel from channel to channel, moderating for all who need your services, and picking up the downtrodden in the wasteland that is Twitch. Enjoy. Don't forget plumbing. It's very important. Plumbing is important. Okay. So hang on, we need to think about this. We can't sub right. If it's high, if it's less than 0, then it's high, but we need to be able to recreate the saved value. You're recreating Wellington, so you don't need to put plumbing. You're making Wellington in City Skylines? Holy crap, that sounds hard. Kind of interesting though. Okay, hang on. How many copies of this number do I actually need? I'm just gonna, so that I can see this running, I'm gonna go mov left down. Let's see if we can step through it a little bit. So 14 comes in, we move it to both directions. and then we swap. Jump equal to 0b, which it is. Oh, we can't though, because we've got to get rid of the extra 14. Okay. Jump equal to 0, skip. And skip is going to be mov right ACC. And save, essentially. Jump B. Okay, let's step through this the rest of the way. Okay, jump equal to 0, skip. Move right ACC. Save. Jump to the beginning. '73 comes in. We swap. Jump equal to 0, skip, which is never going to be true again. Sub right. Jump less than 0, it was high. And we're back at the start. So given that situation, we've lost our 14. So it's almost like that first one was just so that we could test for the 0. Actually, what if on the swap, on the skip, instead of move right ACC, what if we swapped again? Or even just save, right? Like, well, we don't need to save. Move right ACC. No, we can't. Ah, this is pain, man. Yeah, you should totally send some pics. I missed that, but yeah, I used to live in Wellington. I lived in one of the suburbs on the hill, but moved to north of the Bombays for my sins. I like Wellington a lot. Seriously thinking about ordering some dinner at some point. Maybe that's what I need is brain fuel. Maybe I've had too much brain fuel. Okay. So what would happen if I had as many copies of this number as I actually needed? The thing is, I need to retain the original saved value. Or do I? I mean, I've got the storage, right? Maybe I could treat this as random access memory in some way. It's like, but I also need a path out. Or what if this was my random access memory and this was my random access memory? because I need to retain the original value in case it's still the lowest. But I also need to test it, which means I need to subtract from it. So what if this was the memory, or let's call it a cache, and what if this was the memory? And this is solely responsible for storing the lowest number, right? And then we've just got to go move up ACC, move ACC right. And then this one's job is, if it gets a number, wait a minute, can that even work? How do you, because it can only be in read or write at the same time, at one time. So I have to wait for it. I have to either, oh man. It's like I need a writer port to my own memory module. It's not even a memory module. It's just a single value. I need to be trying to receive it. I'd be trying to send a value out of here at all times, essentially. Maybe it just waits to read. And if it reads a 1, if it reads a 0, then it gives me the value. Otherwise, it stores the value. How would that even work? Let's go move ACC, move right ACC, jump equal to 0, output. And output would be swap, move ACC right, swap. And then, or even save or whatever. Oh no, it couldn't be save. And then this next bit, if it wasn't a 0, its responsibility is to store the number. So save. And then jump to the beginning. Okay. So that's a very simple piece of logic that just says, if I get a 0, I'm going to report whatever my stored value is. Otherwise, I'm going to store the value. I could be crazy. This could be just like not even necessary, but let's just think about it. Okay. And except this has got to be left, of course. Okay. So weird. YouTube is so far behind right now that it's playing an ad from like a half an hour ago. Okay. So let's think about this. We've got memory modules. We can store the lowest value or the highest value. Dumb memory modules, but they're there nonetheless. So this is wrong. This is potentially wrong. And so this would be if it got a 0, jump equal to 0 out, and that would be consist of move 0 right, and then move right down. In other words, give me the value that you have stored, and then I'll output it. But otherwise, so same thing over here, move up ACC, jump equal to 0 out. Out is move 0 left, left, and move left down. Okay. So we probably don't have the ability to calculate the lowest number here, right? Because there's not going to be enough room. This one, at the very least, needs to be move ACC down. Hey, Woodstone, how you doing? Down. Oh, actually, yeah, that can just be move left down. Okay, cool. Just want to say first. She can do things now. It's game over. Heat and they can do things. I'm sorry. And that could be. So can we check here? How long is this one problem going to take me? Oh boy. Okay, so let's say let's just even attempt it. Let's attempt it. Let's go like move up ACC. We might need multiple copies of the number. So swap move sub up move ACC down, move ACC down. Might just put a no up in there so I don't get confused. Finally finished work and pleasantly surprised to see you still streaming. Oh, I don't know if I've been a pleasant surprise for anybody today. I'll take that. Sub up. Okay, so we're subtracting from we're subtracting the incoming value from our stored value. Got to learn some Rust. It's been a good day. You got to learn some Rust today. Wow. I don't get to learn Rust at work. I have to do that in my private life. Jump E less than 0, so the incoming value is less than the stored value. To lower. Wait, the incoming value is higher than the stored value. So high and high would be essentially do nothing. But how do we get the value back? Actually, we don't care because we've already, in theory, we've already got the value stored here. So actually, the higher one is easier, isn't it? Let's do the higher one. So if we've got move up ACC, swap, sub up, jump less than 0, high. High is move up, down. And then this, call that begin, jump begin. And then this higher number would move down here. We jump equal to 0 out, but it's not going to be 0. Out is move 0 right. But instead, we're going to move ACC right. And that will save it in our cache. Jump beginning. You learned it by watching me. Oh, I see. I misunderstood. I thought your work was like giving you classes or something. That would have been cool. All right, so move up ACC, swap, sub up. If it's high, then that means that this number, this incoming number was higher, and I can move the second copy of it straight down. The trouble is, I need yet another copy of it to store. Or actually, no, I don't. What am I saying? Move up, ACC, save, move ACC down. Yeah, easy. So that's actually, what would you do if it wasn't though? Where do you get the how do you get the value back that you just subtracted? Hang on. Okay, take the number 14. No, actually, take the second stage. So we've got 14 stored, and we get 73 coming in. So that goes into ACC, and then we swap them. So 73 saved, 14's there. And then we sub up. Oh, so we've used 2 copies of it now. So it becomes 14 minus 73, so it's negative. We need a third copy of the number. This is probably the worst possible solution. Sub up, JLZ high. Okay, let's assume that it isn't. Maybe it's equal to or low. That means we need to move the third copy into ACC, save, and jump back to the beginning. So we've consumed 3 numbers. By the time we get here, we've consumed 2 of them. So we need to move it up. Oh, wait, no, because we would overwrite it. That's wrong. We need the original number. What we need to do is, instead of subbing it, we need to add it back again. Add up. And then save. So we reverse the operation that we just performed. And then save, and then jump to the beginning. Oh, man. Okay, we could potentially be close to a solution. We might not even need these caches. So let's go let's copy all of this, and it should be in reverse. Jump greater than 0 is low. Move up ACC, save, move ACC down. Yeah. And then down here it becomes move ACC left, jump B. Okay, so there's no way this works, but let's just see what happens. Okay, so we've got 14s here. We swap, sub up, jump less than 0 high. So we move the value that's in up into ACC. We save, probably unnecessary on this one, but that's okay. And then we move ACC down. So 14 hits this area. I think the low one isn't going to work because of the 0, but let's just see. Jump equal to 0 out, which we're not. Move ACC right. Jump B. And we save. And now we've got the highest number stored here. Okay. Scary, but true. How are we doing elsewhere? 73 has come down as the highest number, which is true. Saved it. Jump back. What's the next one coming through? A 0. Hey, Alien2, welcome in. How you doing? I am playing a game called TIS-100. I know it doesn't look like a game. It looks like assembly language, which essentially it is. But it's this thing. Basically, this guy named Randy died. He's your uncle. And he left behind this computer. And he's left lots of cryptic notes inside. And you have to unlock them basically by solving the puzzles. Literally, it's the assembly language programming game you never asked for. And I am not particularly good at it, so I'm taking a long time, and you're in the ads. I do apologize. Okay, so is it going to terminate this one? Properly. Oh, it's never going to pass the 0 down because it's never higher than what's stored. Okay, so that's not right. But it's actually promising. I think we can make this work. I just didn't realize that you needed to pass so many copies of the number in order to make it work. Okay, so first of all, we need, if it's a 0, we need to send it out. And I'm not sure if we have the space to do this, but it's 50% off. It's like $5 New Zealand. And so worth it. But I guess you kind of have to like that kind of thing. They make, these are Zachtronics games, and he makes like a bunch of other stuff, including Space Chem, which might be more approachable as another puzzle game. Really interesting, really complicated. And Shenzhen IO, which is about being a new employee in a Chinese electronics factory. Fake chemistry. Boy. Okay. I must not fail in my duty to this computer. I must not fail. So jump equal to 0 out. I don't know if we're going to have space for this. This is going to be tricky. Because not only do we have to pass the 0 out, we have to consume all the extra copies of it because there's 3 of them. Yeah, so let's try this. Out would be move up ACC, move up ACC, move ACC down, and jump B. And I don't think we're going to have enough room, but let's try. Because this is getting real crowded now. Yeah. Let's see. Let's run it through real quick. I'm going to put a breakpoint on this one just to see if it actually works. Okay, so we did actually hit it, and what's stored is 73. So in theory, our first output might be correct, even if nothing else will be. Yay, we got one. Success of a kind. Okay. Interestingly, yeah. I wonder if we can duplicate this on the other side. I don't actually even know if we needed the storage, but maybe we did. Okay, let's get rid of this. Copy this. And then there's bound to be so much redundancy here, but let's just give it a go. This is all about giving it a crack. So the things we need to change are J greater than 0, low, and this is low. So this column's looking for less than 0, this lowest number, this one's looking for highest number. I'm going to run it because I've got a breakpoint anyway, and just keep running it, basically. Okay, so we output 0, so that was definitely wrong. And that's because 0 is our terminator, but 0 is always going to be less than whatever number we're storing. So that can't be good. That means we need a special case for dealing with it. And we're basically out of room, so I don't even know if that's possible. Let's see here. The case is when we move a number in here and swap, the very first time the program runs, there'll be a 0 in there for the very first case, but never again. So we just need to understand how to deal with that case when we've got no space. So ideally it would be something here. When we swap, we'd go jump equal to 0, B, or something like that, just to skip it. But we've run out of instructions. So I need to find a way to either make things more compressed or wait a minute, you can't. I saw in the manual that there was a comma. Let's find the manual. This is the manual that comes with the game, and it's like a cryptic, sort of pretty low. It's got a letter from the auntie that found the computer in it. They're in shock from Randy's passing, and it's got little pansies on the paper. But I'm sure I saw an example of an instruction that had a comma in it. It tells you about how everything works. at least to an extent. Yeah, move 8, comma ACC. I don't know about that. I think that comma might have been a mistake. Oh no. It might be optional. I don't think it separates multiple statements or anything like that. Okay. Got my hopes up, but no. So, how can I make this more efficient so that I get an extra instruction I can use? Add up. Save, jump B. Out. Move up ACC, move up ACC, move ACC down. Wait, that might be wrong. We've already done it once. Oh no, that's right. Jump B. Move up ACC, save, move ACC down. How do I fit another instruction in? Or actually, could I do it up here? No, because I'm swapping here. Could I use the top one as the... Is there any way in which I could always save first? In which case the 0 would get overwritten. No, because I've got to have that previous value. In which case this thing is acting a bit like this storage here. So maybe this is unnecessary. Because we've got all of the logic implemented in here. If we swap and we subtract, all we need is a jump equal to 0b right here. No, actually we don't, because we'd still have to get rid of the other two values from up here. Damn. How do I do it? I've run out of space. I'm out of space. Oh. Sorry, my partner's just sending me a message. All right. Let's think about this. We're close. We are so close, I feel like. I just have this one case where it's going to fail consistently. There might even be a hacky way around it, like if this is the first value you receive or something, but so close. I'm already cramming in the labels as much as I can. But I might be able to save an instruction somewhere. But even then, I just don't think it would help. This one works as is. So I wonder if there's a way that we can split the workload of this one into here somehow. So we jump equal to 0 out, and then out is clearing things. Otherwise, I wonder if swap, and then we take this and extract it somehow. into here. And just kind of outsource some of this work to our compatriot over here on the left. Yeah, so we swap. If it's 0, jump equal to 0, clear, or skip, jump B. Well, actually, there's more to do, but we'll do jump B there for now. And skip would be to move up ACC and move up ACC. So in other words, just get rid of all the extra values that we're not going to use. And we can always compress this if we need to, but otherwise, we need to move ACC. No, hang on. After the swap, move ACC left, swap, move ACC left. Hang on. Can we do this in less instructions maybe? We've already swapped, so we're moving our stored value left. Then we swap again. Or actually, we could just consume another one rather than swapping. Dexter walk time, excellent. Enjoy bus stop hopping. Move up left. And then we move whatever value comes back. That dog, I swear that dog is known to more streamers in New Zealand and Australia than anyone else. So we should have 3 copies of the value. We've already taken 1, and then we 2 and 3. Hang on, so one of them is stored. Move ACC left. So that's the stored value. We've still got 2 of these up here. Move up left and move up left. He's world famous and a very good boy. He's better than my dogs. My dogs are misbehavers. And then potentially move left ACC. And save. Yeah, I don't know if this is going to work. Let's just map it out. See if we can do it. Do we even need to skip? Do we have to jump? Or is there a way that we can just guarantee? Is there a Dexter remote? I didn't know that. There so is. Wait, what's the judge? Oh, he's judging you? Okay, I got it. You need to do a better one, yeah. I have no dog emotes. All right, have a nice walk. Okay, so we've moved the thing that was an ACC, which is the stored value, and then we've moved a copy of the new value across here. So let's say we have B, move right ACC, swap, save, move right ACC, and that gives us both values. Actually, sub right. I wonder if you could just always move all three values left and then just store whatever value came back. What would that look like? And then the logic could live over here in theory. So that would look like you wouldn't have to have this skip. You just swap, move ACC left, move up left, and I mean, it wouldn't really matter. You've already put one in ACC. And you can always pass another one if you need to. And then move right, left, ACC, and save. Jump B. And then you've got out. I don't know if that makes sense, but I think we could try it. So move right ACC, and then if it's 0, which it's only ever going to be once, we can go jump equal to 0, skip. And then skip is move. We've got 3 values to process. Or maybe only 2. Let's see if we can get away with 2. Move right ACC. Move right ACC. Or actually, we've only got 2 left, so this can just go straight back. Move right, right. And that handles the initial case. And we've processed 3 values, the stored value and 2 additional values. Okay, what if it's not 0? Then we have to go sub right, but we need the original value just in case that's the one we're keeping. So we have to go move ACC up, and this one just has to go move down, down. So it returns it, acts like a little register for us. And then sub right. And then if it's greater than 0, then the value being passed in is lower. So jump greater than 0 to low. And low is move right, right. and move up ACC just to get rid of it, and then jump B. And then high would be, we want to keep the value up the top. So move up right. Oh, well, actually, we'd have to consume the previous one first. So move right ACC and then move up right. Jump B. I have no idea if this is going to work. All right, we still got a breakpoint, so let's move the breakpoint here. Actually, we'll probably need one in here somewhere, but let's just run it to see what happens. Okay, so we've got a value. Actually, we have no value. So how is it even... Wait, what? What happened there? Oh, it's just running idle. Okay, screwed. All right. So there's a case that I've missed somewhere in there. Okay. Take a moment's pause while I respond to a message. Plus or minus. Seriously considering some food. Starting to get to that stage. It's getting to that stage where the food must be consumed in quantities of some kind. You would think. You would think that would be the way to go, right? You would think that one would need to order some food at some point, because one is not cooking tonight, because one's partner is elsewhere. Yes, one might just have to do this. It feels like the thing to do. It does feel like the thing to do. Yeah. Okay. That would be the way to go, I do believe. Yes. All right. That is that taken care of. Now then, let's see if we can resolve this. So let's put the breakpoint here-ish. Actually, let's just step through. Okay, so we've got 14 coming down. We swap. So we got 14 stored and 0 in the register. Move up left. Oh, do we never move ACC left? Oh, we need to do that. That's definitely what's going on there. Excuse me. So swap, move ACC left. Move up left, move up left. Yeah. Just try running that again, just real quick. Nope. So he must have moved to 0 down. Oh, this out is wrong. Move up ACC, move up ACC, swap to get the stored value, move ACC down. Oh, okay. So we never hit out now. Oh, yeah, that's... We're required to send a 0 down at some point. Oh, this is hard. J... Oh, no, hang on. Jump equal to 0 out. Out is... right. Okay. I gotcha. So why does it work on this side? On this side, out is move up ACC, and move ACC down. That's to clear the other two zeros, I see. So the whole point is that somewhere along here, we move... Right, the high-low testing. So every time we get a value here, we need to send it down. So move left ACC, save, and also move ACC down. I'm about to do some adds by the looks of things. Okay, we got a 14. That's progress. Let's run it. Oh my God, don't tell me it's going to work. 11. Oh, I think... Oh, no, we lost. Damn. All right, so hang on. The first two were right. This one, we still haven't got a value. Why is that? Excuse me, just a touch of hydration there and caffeine. And we got some ads. We got the ads. Excuse me. All right. Yeah, why are we not getting a value here? What's going on here? We've still got 11 stored in there. We should have had... So 11 was correct there, but we should have had a 50. Oh. I think we're not clearing the value once we're done. So once we get a 0, we do actually need to clear... We need to save, right? So we need to 0 this out, or at least... Huh. Yeah. So maybe we do need to handle zeros all the time. Because otherwise, how will we know? Oh man, this is so tricky. I almost feel like I'm going to need a box. This box, I'm going to need this box on the other side. Oh. Okay, we can do it, maybe. Maybe we could do it. When we get out, we need to save. And I think that will actually make this side work. Okay, first one's correct. Second one's correct. Third one's going to fail on the right. And passes on the left. Interesting. Oh, we're so close. Look how close we are. Oh, man. Okay. Very, very close. But I don't think we can make it work over here because we don't handle the 0 case. Oh, maybe we do. Maybe I can. I mean, it'll just get overwritten by the next number, right? So I just need one more instruction. In out, move up ACC, move up ACC, move ACC down, save. I need a save in there. And I just don't have another instruction left. High is move up ACC, save, move ACC down. Come on, I must be able to get one more instruction in there. Must be able to. Oh, that's so tricky. How can I get one more? Move up ACC, jump equal to 0 out, swap, sub up, jump less than 0 high, add up, save. So this is like restoring it. Jump beginning. Is there any way you can do an operation which saves and adds at the same time? I don't think there is. Move up ACC, move up ACC, move ACC down, save. I can't fit it. Oh, that's so tricky. I just need to zero it out. Or at least... What if I subbed up? No, I've still got to clear it. I'm one instruction away from finishing. One instruction. There's got to be some way to do it. Jump less than 0 high. Could I, otherwise we add up and restore it. But hang on, we're swapped. Let's look at it. Let's look at it running. We've got 14 in ACC and 0 here. Jump equal to 0 out, which is not true. Swap. Sub up. Negative. If it's less than 0, it's high. Which means we move up into ACC. We save. Actually, that save is not necessary, right? Or is it? Because it's already there, but what happens if... Actually, maybe it's not. In which case, we've got an extra instruction and we could... save, move ACC down. Let's try it. I doubt it'll work, but you never know. Oh, is it going to work? Oh, I think it might work. Hang on, this is the test. I'm taking the breakpoint out. I think this is going to work. Oh, it's very exciting. Come on. Come on. This is like at work, just waiting for the test to go green, man. Come on. Come on. You can do it. Oh, I got a feeling. I got a feeling it's going to work. Oh, man. It's going to work. 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 I think it's going to work. There is no way this is the most efficient solution to the problem. I cannot believe it. If it fails on one of these last ones, I'm just going to cry. I'm just going to cry. Oh my God. It works. It works. It works. It works. Look at my instruction count statistics. Right up the top. There must have been a really simple solution that I just didn't know about. Oh man, one of these days I'm going to go back over other people's solutions and just, holy crap. That was so hard. All right. I wonder if we actually needed these side cache things. I actually don't think we did. I think we could have implemented it with just this and not use those caches at all. There's probably lots of refactoring we could do in this. Like maybe we didn't need 3 copies of every number. Oh boy. Okay. The trouble is that I think each previous step teaches you what you need for the next one, and I'm not sure if I learned the right thing. But we made it all the way up to here. That's exciting. That is exciting. Oh man. Cannot believe that. It was so tricky. Okay, maybe we should just peek at the next one. I don't know if I'll finish the next one, but we'll look at the story element for it. Sequence reverser. Okay, create new program. Stack memory node? What? This is new. I've never had memory before. Ah. Okay, what's the debug? When I get into a groove working on this machine, it feels like I'm in the presence of a being that understands me. Forget all about life that pains me and drags me down. I want to be a tessellated intelligence. Take inputs, process, take inputs, process, take input, process, perceive, understand. I think Randy is losing it. Frankly, I think he's losing it. I think he's going down into that hole where the bits and the bytes live. And I don't think he's coming back out. I think this is going to be a bad ending. And I think that, to be honest, we probably should find somebody to raid out, because it's been something like 6 hours now. I think I could be going down into that hole with the bits and the bytes. Let me see if I can find somebody who might like to get raided. Grumble of Pugs is on. He's off and on. We got some... Depends what you want to look at, really. Got some Rust. Grumble of Plagues is interesting. He's doing a he's creating a game about a fruit bat. It's a fruit bat with superpowers. It's pretty interesting. Yeah, maybe we'll go raid him.
Now, if we run this again, should be fine here.
But thanks very much for hanging out. I really appreciate it. I'm gonna have a little dinner, maybe chill, maybe play some games that don't involve assembly language.
Cool. All right, so I just feel like this isn't very obvious, but
I really appreciate your company.
I think we'll probably just leave it in, and then when people play test it, I'll like watch them, and we'll